Okay, so this section is related to calculate the force on a curved immersed surfaces. So imagine that you have a surface like this one. This is immersed surface under the water surface. And we want to just calculate the force applied from the water to this kind of like the surfaces. As you can see, like the pressure has got like the angle of the 50 degrees. So it's just going to be like the right angles. It looks like, for example, a curvature shape. So you can see like a curvature here is created here. And all of this kind of like a pressure diagram. It's just gonna have like a center crossing through the center of this curvature, or through the center of this kind of like the curves. So you can see here some of the like forces are horizontal and some of them are vertical, and some of them are inclined like the angles. So all of them together, we can divide this kind of like the forces into two components, horizontal F, or the horizontal force, and the vertical force. And we can easily calculate each of them separately, and then we can calculate the resultant force F. So let's see how we're just gonna do this one quickly in the simple steps that we're just gonna need to do this one. So first one, horizontal forces. If we just consider a vertical projected surface like this one. This is a vertical projected surface of this curved surface. You can see the pressure distribution or pressure intensity diagram over this vertical projected surface. It looks like this one, trapezoidal, starting from here, with a specific value, and ending with this one. So to calculate the resultant force or horizontal force of this one, we need to calculate the centroid and calculate the pressure of that point, and multiply by the area of the projected surface area. So if that point, the depth of that point, the centroid of that projected surface is hg, so we can just write rho g hg times the area. Area A is the area of the vertical projected surface. Bear in mind, vertical projected surface. So this is like a horizontal force, FH. So we need to calculate FV. To calculate the FV, or vertical force, for this case, we can easily say it's equal to the weight of the water above the surface. Weight of the water above the surface on this kind of like a curve or a surface is equal to FV. Or in other words, we can say that the vertical force is equal to the W. So all of the like the force applies to here is equal to W. W is equal to mg. Mg is like the mass of the water. This is like the hatched area here, and m is equal to rho g. So the rho gv actually. M is equal to rho v, and if you just can substitute here, we can have like a rho gv. So the fv is equal to rho gv here. So you're just gonna write it here. Fv is equal to rho gv, and the resultant force, you can use a very simple Pythagoras relationship in the geometry and trigonometry of this kind of like the two sides of this forces, horizontal forces and vertical forces, and the resultant force is the hypotenuse of this kind of like the horizontal and vertical. So F is based on the Pythagoras, can be calculated as the square root of the sum of the squares of the two components elements. So we just have like this one, F is equal to the square root of FH squared plus FV squared. So that is F. And to calculate the angle, the direction of the resultant force, you can easily use the trigonometry relationship, and using the tangent formula, tangent of the theta. If the degree here, we're just going to calculate the theta of the F relative to horizontal line. So we can say tangent phi is equal to the ratio of the FV opposite side to the adjacent side relative to FH, or ratio of the FV to FH. Okay, so that's a tangent phi or phi for this kind of like a calculation. So I'm just going to give you an example for these kind of like the forces, two examples in the next presentation.